So I'm calling from Slovakia. Actually, I work for FireSafe Europe. My professional background is fire testing, all kinds of fire testing, and then I worked also for industry, also for FireSafe Europe member companies. That's why I'm speaking now. And now I'm helping FireSafe Europe on technical projects. So a couple of words about why we started this initiative. Of course, if you are a European association based in Brussels, dealing with fire safety, the obvious topic is comparison of regulations in general in Europe. And then we decided also to use a broader community. So FireSafe Europe is an association based in Brussels, but it's much more than that. We also opened an open forum community, which has more than 650 members now. It's open forum, so you can participate if you like. Well, you're all welcome to participate. And it's a forum to learn from each other, to bridge the gap between European countries, between different kinds of expertise that we may have, and join the forces to bring fire safety at the next level in Europe. So FireSafe Europe was established by companies to raise the awareness of fire safety in Europe in general. We cover a couple of sectors like cables, concrete, insulation, firefighting, fire research, flame retardants, and roof on wall systems. And the community is a growing area where we have more and more experts from different expertise. So about these comparative studies, this idea, as I said before, was actually around for quite some time. We started with comparing European regulations. This was a very tough exercise, so that's we decided to focus on a couple of specific building types. And in 2014, we started the project, and we about comparisons, which ended up in an interflam paper, which caught some attraction. That's why we decided to open this subject to the community and to actually ask people from different member states to give us information about what kind of regulations do you have in your countries about particular building types. And today I'm going to show you results about two types of buildings. I'll show you later that now we are also conducting a survey on a third building type, which is schools. But now I'm going to focus on hospitals, but I simply cannot avoid comparing what our findings with the high-rise buildings, which was the first part of the study. Maybe I can say before I go deeper into this analysis that these are living documents. These are of course subject to revisions, and we welcome all kinds of input anytime. So regarding hospitals, we have something like inputs from 20 countries, including Croatia, also from some people who are present as panelists, so from other countries in this conference. As you can see, this is not limited to European Union. We really aim to cover all Europe. To make this task a little bit manageable, we decided to use a specific example of a hospital. In this case, it's what we are now evaluating is the hospital building with 8 floors, a basement, 35 meters in total height, 10,000 square meters ground area, 1,000 beds. And the building is located in a city with 3 kilometers to the nearest fire station. Of course, we could end up with a quite different analysis with a different building types, but this is what we consider to be a building or a typical hospital that we can find across Europe. If I compare this to the high-rise building exercise and comparison, we get a very similar number of countries responding to that. Of course, it's not covering all Europe, but I think it's quite a significant amount. So we have a similar basis for comparisons. And in this case, what we call high residential building in our reports is that it's a building with 15 floors, 2,000 square meter ground area, 17 apartments in each floor, and the building is also located in a city with 3 kilometers to nearest fire station. Okay, and now let's go into analysis, and let's start with a question that was originally not part of the original survey to the member states and to the experts willing to contribute to the community. We try to investigate from the analysis of the questions we received if European countries have specific regulations for hospitals or not. And looking at the answers, we can see that there can be 3 or 4 possible approaches. So you can see that some countries have dedicated fire safety regulations for healthcare facilities. In some countries, you see additions to fire safety regulations for healthcare to general ones. You have countries that deal with the hospitals as part of, I would say, high-risk buildings assessment. And some countries may look at it and give basically the same results as for high-rise buildings. And then, of course, you have a full spectrum of potential approaches and answers in between. So now, if we come to the real analysis of the data that we have, we had a series of questions asked the community members for their answers, also giving the background on what is the source of their information. I put these 3 questions on a single slide just to show the, I would say, comparison between, or there can be some kind of balance between different measures to cover a risk. So we can see that, for example, in this kind of hospital, the sprinklers are mandatory in approximately half of countries, or more than half, whereas 3/4 of countries require some kind of protection from smoke in escape routes, whereas the minimum number of escape routes differs a lot. It can be very seldom that only one escape route is allowed. It can be more. It can depend on the number of escape routes from a fire compartment or from a floor. And the need for sprinklers may depend also on the height of the building, ability to move, fire load, fire compartment size, etc. It's interesting to compare this to a high-rise residential building, where you see that only something like 20% of countries require sprinklers as a mandatory requirement. 1/3 of the countries allow only one escape route in high-rise, whereas this one escape route must be almost universally protected from smoke, usually in the form of smoke ventilation or smoke pressurization. So this is just to show you different risks and different approaches to mitigate this risk in these 2 building types. Maximum distance to escape routes was another question in our survey. You can see 2 columns in each country, which represents minimum and maximum values. Again, as you can imagine, this distance can depend on a number of parameters. Sometimes you have longer distances allowed if you have more than one escape route, or if the escape route is protected from smoke, or if it's sprinklered, or a combination of all these measures. Maximum distance to escape routes from a fire compartment. Apart from, I would say, one extreme, we have very similar, I would say, a quite similar range in high-rise buildings. Okay, so maybe I didn't mention, but and you may have noticed that this small logo in the top left points to the type of building we are talking about, if it's hospitals or high-rise buildings. In terms of fire resistance ratings used in buildings, what we can see is that typical range is from 60 to 120 minutes. Higher ratings are required in Poland and Spain, because these buildings are considered high-risk buildings. And actually, we can see quite similar picture also in high-rise buildings, where we can see some high requirements, but typically it's also in the 60 to 120 minutes range. Another parameter to look at was reaction to fire, either for the load-bearing structure of the building and fire compartment walls. So in hospitals, you can see that the most typical requirement is A2, S1D0, which would be considered non-combustible in most countries. But you can also see that approximately 1/4 of these countries had no requirement on this parameter. And then you can see just a few examples of other possible ratings. If you look at high-rise residential building, we can also see that A2, S1D0, and also A1 means non-combustible. Load-bearing structure and compartment walls are required in these building types. It's seldom that you can see other possible classes, but interestingly, there is no country reporting that they have no requirement for high-rise building, whereas for hospitals, yeah, it was different. This is an interesting overview of roofs, both in terms of roof coverings, like external exposure classification and roof insulation requirements. You can see a full spectrum of answers. It's difficult to find a common denominator here, apart from the fact that we have B roof, one of these 4 possible European classes mentioned most often. But what you can see is that some European countries require external exposure classification, some require reaction to fire class, and some even indicated flooring. We assume that this was for parts of the roof where people can walk. And for roof insulation, this is we can see a similar picture. Is mostly non-combustible, but a lot of countries have no requirement here. I'm not showing this picture for high-rise residential buildings because it was basically the same or very similar overview. External wall claddings. We have seen some examples of tragic fires where external claddings were involved. Quite interestingly, 1/4 of the countries didn't report any requirement for external wall cladding in hospital, and for countries which did require requirements, it was mostly A2, S1D0. It was never A1. I assume it's for practical reason, because it's very difficult to find products which would conform to this requirement. And what you can see is the overview of 3 different technologies. It's for ventilated facades, it's for cavity walls, and attics, the rendered facades. Just comparing this parameter to high-rise building, what is striking here that it's only 1 country reporting no requirement for this building type, and for majority it's some sort of non-combustibility or limited combustibility, mostly in the category A2, sometimes also B. Some countries in Eastern Europe, this was reported by Poland, have a special requirement that they require a certain height of the building that must be non-combustible, meaning from certain height above, but below you can have different rating. But this is not universally, I would say, seen elsewhere. Another parameter was reaction to fire of wall and ceiling linings, and I put these two graphs on one slide because it also shows an interesting comparison. In hospitals, wall and ceiling linings, you don't see actually very big differences between escape routes, shown in green, and the general requirement for other types of premises in this building, shown in blue. In residential high-rise building, it's a bit different. Escape routes are protected more than in the apartments. But we don't see this split so much in hospitals. And a similar picture is in floor coverings. In hospitals, floor coverings in general are not required to have high requirements, with some exceptions, of course. Typically, we see the C class here as a requirement. Whereas for high-rise buildings, we can see that floor coverings are more heavily regulated in escape routes, so with much more limited regulation in apartments. Pipe insulation and cables. This can be again a very diverse picture. Difficult to make any, I would say, common denominator or conclusion for all Europe, especially for cables. We can see full spectrum of possible answers. Not different in classes and results reported, but also different in the way how this is approached and regulated. So you can see reaction to fire to cable classification. You see some national classes. You see some IEC standards, electrical standards here, and a lot of countries report no requirements. But we also assume that different premises in this building can have also different requirements here. And again, I'm not showing high-rise buildings because this is basically a very similar overview. We also asked about furniture, and just looking at the answers provided by countries, we saw that we could potentially have two types of replies. Some countries reported about requirements on fire safety properties on furniture. There were just a few that had this requirement, but others gave information about furniture, if it can be present, or what are the limitations in hospital rooms and escape routes, and related safety issues like blockage, resulting fire load, etc. But yeah, we can see that approximately half of the countries do regulate on this parameter in hospitals and also in high-rise buildings. And the last question we asked was the possibility to apply fire safety engineering tools to design this kind of building. You all know that European Commission is interested in a way supports this development, and we can see that approximately two-thirds of European countries allow fire safety engineering design of hospitals, but almost all of these countries, and we could see that in the comments, indicated some kind of control over the process. Typically, it was required to prove equivalence with prescriptive requirements or try to use conservative approach. As I said, this project is not yet over. It's a work in progress. Now we launched a questionnaire, a survey on the community site about schools. So after we have these three buildings types covered, we'll have an overview of the situation in Europe for three building types. But we also assume that we will not get answers from each and every member state. That's why I strongly encourage you and invite you to participate really in these efforts, because the output can be only as good as the inputs provided. So any kind of support or participation in this initiative is really appreciate it. And thank you in advance for that. And thank you also people in this conference who provided very valuable inputs for hospitals and high-rise buildings. So that's all from my side.